Okay, so this is the only problem that we unfortunately were not able to get to in class this week. So the directions are: write a linear equation for the following problem. Graph your results when finished. Do not forget to define x and y, and do not forget to scale your graph appropriately. Must use Kissor to solve. Now this is probably the fourth or fifth test that I've asked you to solve a problem using Kissor, and previous times some of you have failed completely because you didn't use Kissor. So please use Kissor. Here's the prompt. It says if a cab company charges a $5 boarding rate in addition to its meter, which is $3 for every mile. What is the equation of the line that represents this cab company's rate? So let's start with Kissor. So K, the first K is underline key math words. So $5 boarding rate in addition, I'm only gonna underline the addition part, and then $3 for every mile. Now, what are we being asked? As far as what we're being asked, we are being asked to write an equation for the company's rate. Now, so that's K, that's I. We've underlined important things, we've identified the question, now it's time to strategize. So, my strategy is going to be, well, what is X, what is Y? If we can define those two things, it'll make things a lot easier. So, looking at the information I'm given here, I always like to go to the end. What's the end result here? So, you're getting in a cab, and you're going to pay a certain amount of money. Now, that's going to change, obviously, depending on how many miles you travel. But at the end of the day, this is all about a cab ride and how much money you're going to spend. So I'm going to define y first. So I'm going to say y is equal, I say represents the amount of money spent for the cab ride. Now, x is going to be something that we don't quite know yet, but we're going to have our equation is going to be y is equal to, now looking back at the prompt, what we don't know is the thing that changes a lot. Now, if you look carefully here, we have $5, we have $3. The $5 is for the boarding rate, so that's going to happen no matter what. So that's going to be part of our equation, so we're going to have 5. Now, we also have the word in addition. So that's kind of telling me that I'm going to add to that $5, so I'm going to add that to my equation. And it says, on the previous slide, it says we're going to add $3 for every mile. Now, every mile is the mystery here. We don't know how many miles we're going to be traveling. We can be traveling, within the city. We can be traveling, within a state, which is a lot, more mileage. So that's what, our mystery is. That's the x. So I'm going to go ahead and define x. X, represents the number of miles. And I just realized that is here doesn't really work. So x represents the number of miles. So $3 per mile. We're gonna pay $5 no matter what, and then our total cost will vary depending on how many miles there are. Okay, now from here, this kind of looks like y equals mx plus b. Not quite there. The only difference is, well, if we switch the order in which it's in, which we can do because it's addition. If it were subtraction or division, it'd probably be way different. But because we have addition here, we can actually switch the order of these two. Now, this right here, that's going to be my slope. This right here is my y-intercept. So slope is 3 over 1. So m is equal to, I'm actually going to write this because fractions are a little difficult to do in this program. And then we also know that b, which is our y-intercept, is going to be 0 and 5. So using this information, I now have to create a graph. So I'm only going to be working in the first quadrant because we're talking about money and we're talking about how much you're going to pay. So that's always going to be a positive number. Now this is going to be y. This is going to be x. Now again, y was amount of money. So it's basically the cost. And then x is the number of miles. Now as far as scaling all of this, I would keep this, as number of miles. Let's go with, well, there's a lot of different ways we can go about this, because if you think about it, you could be traveling a lot, you could be traveling short distance, but I'm going to keep this simple for you guys. We're going to start this with 0, 1, 2, 3, 4, 5. Now over here, you really could do whatever you want. Now, as far as this goes, our first point on this graph, on this line right here, is going to be 0 and 5, and then from there, we're going to be going up 3 and then over 1. So that makes for a pretty interesting, mix of things. I'm going to go ahead and scale this. I'm going to make this a 5. Make it 10. So I'm going to be moving by 5. Now this is going to make my drawing the line a little weird, but I'll actually be able to fit some of it on here. Alright, so my first coordinate is going to be 0 and 5, so that's about here. Now, here's the part where things are going to get a little messy. I have to go up 3 and over 1. So, if I went about halfway, that would be about 7.5, so I need to go a little bit higher than that, and I'm going to go over 1. And I'm going to do the same thing here. Now, this is supposed to be 8, so if I'm going to go up 3, it means I'm going to go to 11. So I'm going to, again, I'm kind of estimating here. If I had more tick marks, it'd be a lot better. And I'm going to go over 1, so it's about right there. Now, at the end of the day, you want a straight line. So, when you're going up 3 and over 1, you should kind of eyeball it so that it looks like it's going to be a straight line. Now, this right here is 14. I'm going to go up 3 more. It's going to be about 17. So, if I went up just a little bit like this for 11, I'm going to have to go up a little more to get that 17, to get 2 away from 15. I'm going to go over here. And it does look like a straight line. Let's see what we can do with this. It's not going to be perfect, but that's basically it. Now, this is miles. We only really went up to 5 here. I only graphed up to 4. Realistically, if we wanted to, if we were working for the company, we want to make these a lot bigger. We'd scale this a lot differently, because this right here is only up to 4 miles. Even if I kept going this way and extended my line, I can still get some of the answers off of this, but it's not going to be the best. But at this point, I just want you to get some of the basics down. We will do something more intense, more detailed at a later date. If you guys have any questions, please feel free to send me an email.